So why don't you start with introducing yourself? Like, what do you do? What is your experience? What are your aspirations and stuff like that?
Yeah. Hi everyone. I am Sanket Kumar, currently pursuing my third year undergraduation at Chaitanya Bharati Institute of Technology, Hyderabad.
Okay.
I am pursuing a course called Computer Science and Engineering with a specialization in Artificial Intelligence and Machine Learning, uh, like a 4-year course. And coming to like my technical experience, I have been as an intern with like 2 or 3 organizations. Firstly, with or International Institute of Information Technology, Hyderabad, like Triple IT Hyderabad,
Triple IT Hyderabad. Yes.
where I worked as a research intern under Jawahar sir, where we worked on a project called INAI, which is a collaboration with Intel, which was actually launched by the Telangana's IT Minister, Shri KTR Garu.
Oh, awesome. Yeah, I am a big fan of that person. I have seen many videos of him.
Yeah,
Pretty spectacular minister, and also he's doing a lot of good things.
yeah.
So
So,
pretty good, awesome thing that you've done. And
and the other thing is like one of the internship was related to the college regularity, where I was a part of Panacea.ai, which is like an open source forum where you can like give contributions, and then work on something called as like nutrition recommendation system. So there we worked
oh,
on
okay,
something related to nutrition recommendation system. And like coming to my hobbies, I love watching cricket. A big fan of Virat Kohli and
okay,
RCB. And
awesome.
yeah, I love listening to music and just do LeetCode or like learn. And my the ultimate goal of mine is to like settle at a good company, a reputed FAANG company.
Okay.
Yeah.
Okay,
So
that's pretty cool. You couldn't have picked better time to join AI.
yeah,
It's been making headlines all across world. So
yeah,
definitely, yeah, you have a bright future there for sure. Like myself personally, I'm also trying to learn more about AI. Trying to understand that how like machine learning models work, how the things work the way the way they do. So
yeah,
pretty interesting that you are already doing it, and love your experience with Intel. Uh, Looks like you already have pretty impactful thing that you can show that hey, I have already worked on this, and Telangana government actually launched it. So it's right there out there helping a lot of people. It has to be scalable because it's been used by what, like 5 crore people, something like that. That's
exactly.
the population. Yeah, so pretty cool in that regard.
Yeah.
So, and what is your expectation from this mock interview? Like I saw that you wanted to have like a medium difficulty level mock interview,
Yeah.
and yeah.
So like speaking more about the depth of knowledge I have in the data structures and algorithms, I am like a beginner kind of person who is like very new to this competitive programming and also data structures, where I'm like well versed as I feel in the machine learning or maybe like the MERN stack full web development. But like data structures and algorithms is something which I'm like loving it, the way I go, the way I do and approach my problems. So I felt like it would be harsh if I challenge myself to solve hard problems, because I'm like very new to it. Like I have been doing it since 5 or 6 months. So that's how I used. But the thing what I would gain from this mock interview is like the way I think when I'm like pressurized, when I'm in a pressurized situation, like how do I think and get the most out of it? How do I uh, represent myself better? So that's like coming to my like past interviews, it was very different from what the FAANG interviews will be. Like that was totally into machine learning and AI, where they like literally ask you the theoretical part of machine learning. But this thing is I'm like very new, and like in coming 3 or 4 months my campus placements will also begin. So this would like be the best step I took in that way.
Yeah, probably. I think it only you only get better with practice. And honestly, like speaking from my personal experience, I wish I had started doing this when I was in college or stuff like that. I was too late. I probably started when I finished my bachelor's, finished my master's. I was already working in a job for almost 5 plus years, and then I thought that I should start learning DSA. And so you're already 10 years ahead. Kudos to that. Let's get started. Cool. So let me just paste the first question here. Uh, Basically, it's saying that suppose you are climbing a staircase and it takes n steps to reach to the top. Now
Okay.
it can be like 5 steps, 10 steps. You don't know.
Okay.
Now you have the option to every single time you can either climb 1 step or 2 steps. So the
Mhm.
question is, in how many distinct ways can you climb to the top? Now let me give you a couple of examples for this.
Sure.
So suppose you are given as an input like just two. Suppose you are given that there are only 2 ways. Definitely there are 2 ways to reach to the top. First one is like you just take 1 step and then 1 step again, or you take 2 steps directly. Say for an example, you are given an input 3, then the number of steps would be basically 3. That you have the option 1 plus 1 plus 1, 1 plus 2, or 2 plus 1.
Got it.
Yeah.
So, can I like assume that you're like on the step 0 kind of thing? Like,
Yes, you are at the bottom of the staircase.
okay, got it.
Yeah. Yeah.
Uh,
So the
and
first step you would take, you would end up at like first step. Basically, that's
got it.
yeah.
And like, what might be the constraints, like the range of n, like the upper limit?
Okay, so it wouldn't be too huge, because otherwise the complexity would grow too much that you won't be able to compute. So let's just say n to be less than like 30 or 40. It's going to be a reasonable number that doesn't break like computer capacity.
Understood. Understood.
Yeah,
Okay, give me a minute.
sure.
As I can like go through the second sentence of the question, it is like that you have at an ith step, like let's say you are in the ith position or maybe the ith staircase stair, and you have to like select among like the two options. Like you can either take one step forward, or you can like choose 2 steps to reach the top of the staircase. uh,
Perfect. Yeah.
so so I feel like you have to compute like the number of ways you can reach to the top. So I feel it is somewhere like related to the recursion. Like you are at the ith stage and you have two options to choose. Either you go to the I plus 1 step, or you go to the I plus 2 step.
Yeah, correct. Every single time you would have the option to choose whether you want to do one jump or two jumps, and
Yeah.
basically you would be able to add the number of possibilities you can make. So yeah, spot on that.
Yeah. So should I like tell you like what algorithm I am thinking, or like shall
Yeah,
I?
of course.
Yeah.
Go ahead. So go ahead. What is your expectation? What do you think should be?
Yeah. So what I feel is like, let's say, okay, let's say you are like in the ith step, and you have like some more to reach to the end of the top of the staircase. So here you have like two possibilities where you can actually take one step to reach to the next place, next index or whatever, and you have another choice of taking 2 steps to reach 2 steps later in the staircase. So that is what I'm thinking. This will happen recursively till you reach to the top of the staircase. Am I making sense?
Oh, sorry, I was on mute. Yeah, I think you make sense that you would continuously have to do this repeatedly.
Yeah. So should I like start coding it up?
Do you think this would be like the final solution? Are you able to think about some constraints? How would you be able to make it more efficient? Can you give me a quick walk down? So suppose given n is equal to 4, what would be your
Okay,
approach?
sure, sure.
Yeah, something like that.
So
Okay.
yeah. So n is equal to 4, and let's say you are like on the bottommost, like zeroth
You are currently
staircase.
at the 0th staircase.
So you can like possibly take ways as like one step to reach one step to reach 2 and 3 and 4. Like this
Yeah,
is like
that's number
taking
one. Yeah.
and you can actually take 2 and 2 and reach to the top of the staircase. That is like one
I
possibility.
mean, yeah, I don't want to see. I got that these are the possibilities you would be able to make, but how would you actually compute? That is the question. So what would be, you are saying you would use recursion. For
Yeah.
recursion, you
So I
probably
would
need,
write a base case in such a way that if you reach to the top of the staircase, I return 1 there.
okay, okay.
Or
So
maybe like
basically,
in the reverse order. Like if you are standing at n, and if you reach 0 or something less than that, you return 1.
okay. So which approach do you think? So bottom up approach, so where you start at 0 and end at 4, or top down approach where you start at 4 and come back at 0? Which one do you think would make more sense?
Okay, so one now if I can like think, I feel this is somewhere related to the pattern of Fibonacci sequence, because you are like taking 1 or 2 at a time. That is how the Fibonacci starts. So I feel like pre-computing till I, and then like going from I to the later one will be better, like the bottom up
Correct.
approach.
Yeah, okay. Yeah, perfect. I think that would make more sense. You are spot on there.
Yeah.
So sure. I think your solution makes sense. For recursion, typically we deal with two things. We deal with a base case. You already mentioned the base case, that if you reach step 0, you would return 1. That would be your base case. What would be the recurrence relation in this case? And how many recursive calls would you make?
So I'll like probably make 2 calls, uh, like one for 1 step and the other for 2 steps.
Okay, perfect. Perfect.
Yeah.
Yeah, I think I'm good. You can go ahead. And what would be the time and space complexity? Or you want, if you want, you can also calculate that after the code as well.
Yeah. Let me write the code and then it would like make more sense.
Okay, cool.
Yeah. So I'll be coding it up in C++.
Sure. Yeah, don't worry about all of these libraries, though. You don't have
Okay.
to go so much deep.
Okay.
Yeah,
Okay.
yeah. You can
I'll,
just
yeah.
start. So suppose, okay, suppose let me also give you the method that you need to implement.
Sure.
Suppose you are given a simple method
Okay.
where you simply, okay, this one is Java, but you can consider equivalent
Okay.
of, okay, let
I
me,
can like remove it. Yeah.
here I can, C++ you said, right?
Yeah. Yeah. Yeah.
Yeah, okay, okay. So here is the C++ method. So climb stairs that returns an integer value. Basically, the integer defines that how many number of total ways you can reach to the top. And in the input, you are given a value n. That is pretty simple. So you can start coding from here.
Yeah. So what I feel is like if n, which is like the number of stairs you have, if it is less than or equal to 0, you return 1. Okay, so you are at the ith step and you are coming back. That is one case. Okay. So what I feel like, I'll have like 3 cases where you are at 1 and you are at 2. So if you are on 2, you have like 2 ways, as we already know, like the pretty straightforward thing. So if you are on 1, then you have only one way to get to the bottom, or maybe like to the end of the staircase. So I would say n is equal to 1, you return 1.
Yeah.
Else you return, oh, my bad, like this is 0. Else if n is equal to 2, you return 2. Else you have like 2 ways of computing. So you return taking 1 step, and you also have to take 2 steps. So you have to give like the total possibility. So I am like summing them up. uh,
Perfect.
yeah, I feel like this should work. So you take 1 steps recursively, it will compute like the number of steps where you took 1 step from the ith, and this will compute the number of ways you could go down where you are taking 2 steps at a time. So I feel this should work.
Perfect. Yeah, I also think that this can work.
Okay. So what I feel about the time complexity is like at a given stage on the staircase, you have like 2 possibilities. So I think the complexity will be exponential. That is like, let's say it will at least be 2 power of n. Like you have two combinations of like picking them up. So I feel it is 2 power n. But I don't think it is exactly 2 power n, but it is exponential.
Okay. Do you think you would be able to bring the complexity down to something in, let's say, linear time?
Okay. I feel yes, because like let's say you are at the fourth step, and
Yeah.
you have to like reach to the bottom. As we already know the steps taken to reach to the two, you can actually store the steps taken to reach to the every step throughout of what you are like computing. So I what I mean to tell is like I'll probably solve the smaller variations or the smaller sub problems first and store them in a list and then tackle the larger sub problem.
Of course. Yeah. So, and what would that do with the time complexity?
And it will like drop down to big of n. But
Perfect.
the space complexity would also be big of n. Like,
So,
in
which one
the
do you think would be better in this case? The exponential one or the one with space complexity of being big of n?
Yeah, so there I feel like it will always be the trade-off between the time and space complexities, but I feel like generally we tend to reduce the time complexity as much as possible. So I feel this solution of storing it in let's say like the DP array or whatever uh, with an extra O of n space will be a good trade-off to actually
Cool.
implement. Yeah,
Sure. So one more thing here. Say
yeah.
one example, if you still want to do in space complexity of big O of one, would you be able to think of any solution that achieves even the space complexity to be big O of one?
Okay. Oh, yeah, yeah. Actually, yes. Because you are actually dependent on only the computations of like the previous two cases. Like when you are standing at the ith stair, you only you only are coming. You only arrive at that particular staircase just because either you took one step from the previous thing or two steps from the uh, like the leftmost step of the previous step. So you only need like two variables kind of thing. So
Perfect. Perfect.
I will remember like the previous and the current, and the next will be computed by the sum of previous plus current.
Cool. So I think that solution would be able to give you the time complexity of big O of n and space
And space
complexity
of
of
big of one.
big O of one. Yeah.
Yeah.
So do you want to go ahead and quickly code that up?
Yeah, sure.
Sure.
Yeah. Okay. Okay. So I am starting at the zero step. Uh, Okay, so you need like the number of steps as well, global. So how does this go? Uh, so this thing I can like basically write this will be like the sum of the previous and current thing, and like you have to reinitialize the variables of previous and current. So now the new previous will become current, and current will become steps, and at the end like you return steps. Okay, let me like dry run 0. Okay, so instead of current, like I can take I here.
Okay. Do you think in this case, rather than using previous and current as 0 0, if you start with, like, if there are only one step, you know there is only one way you can reach there, right?
Yeah.
So
Okay.
suppose you can, if you
I
take
understand.
one step, you can reach one. If you are given two stairs, you can, there are only two ways you can do that.
I get it. So we'll
And
initialize
yes,
previous and current with 1 and 2, maybe.
yeah. Now,
I think. Okay. Yeah. I think this should work.
yeah, I think this would work. So basically, suppose you are given like the, you know, for university you need to have prerequisites for any single course.
Sure. Yeah.
Yeah, like if you want, you can, like if you want to complete comp 202, you need to have completed comp 101 before you can enter to the next step.
Understood.
Now, suppose you are given a prerequisite array with a tuple like format like AI and BI, where it represents that you must take BI course first if you want to take AI course, like A of ith position course. So you need to check that based on the given input, are you able to finish all the courses? Or basically, are you able to schedule all the courses? If not, you can return false, saying that because there are some dependencies that does not meet up, uh, it you are not able to schedule. So, say for an example, suppose you are given a dependency like in order to complete course one, you need to
Okay.
complete, let's say, course two, and in
Okay.
order to complete course 2 you need to complete course 3. So
Okay.
this is the dependency. In this case you can clearly see that all three cases you are able to complete because there are no unexpected dependencies that you can't compute. But suppose you are given a dependency like in order to complete course 1 you need to complete course 2, in order to complete course 2 you need to complete course number 3, and again in order to complete course number 3 you will need to complete course number 1. So in this case you would never be able to complete all three courses because basically one is dependent on the other and other is dependent on the previous one. So this, there is a problem here. So this is what you need to check.
Okay. So let me like once read the question.
Sure. If you want, I can give you more examples as well.
Okay. Like give me like one more example where the this thing like fails. So where you
Yeah.
return false.
Here, let me give you a proper example.
Sure. Sure.
Yeah, this is where you would return false. So see over here, in this case, the structure is 1 0. So 1 0 basically means that in order to complete the course number 0, sorry, in order to complete the course number, yeah, in order to complete course number 0, you must have completed course number 1. I think that this is what it means.
Yeah. To take course 1, you should have like finished
Yes,
the second one. So
yes.
BI
And
is
same
first
way.
if you want to take AI.
Yeah, yeah. So in order to complete course 0, you would have completed course 1. So let's just write down over here, in order to complete course 0 you must have completed course 1 before. This
Understood.
is what, yeah. And in this case this one is saying then in order to complete course
You should have completed course 0.
1 you should have completed course 0. So the second scenario is like in order to complete course 1 you should have complete course 0, but you cannot complete course 1 because for that you will need to complete course 0, sorry, you cannot complete course 0.
Uh,
uh, you cannot complete course 0 because for that you would need to have completed course 1, and you
understood.
cannot complete course 1 because you need to have completed course 0 for that. So
Understood.
that this is, yeah, in this case it would also be a fail, false.
Okay. Oh, what is the complexity of constraint of the number of courses or maybe the length of the prerequisites array?
So typically the length of prerequisites array is it's going to be less than 5,000 values,
Okay,
and the number of courses would be somewhere between less than 2,000 courses. So it would be uh, it would be basically in the bounds that it can be computed quite easily by any computer.
got it. Okay.
Yeah.
So
And
what? Yeah.
one more thing, as an input you are basically given a method like this. where you are given the number of courses and you
Sure.
are also given the prerequisite array that
Understood.
contains like the tuple int values.
Understood. Are the prerequisite courses zero based indexed things? Yeah. Okay.
So it's it's a normal indexing. Like
Yeah.
starts indexing starts with 0.
Sure. As I can see, this is a problem related to the graphs. So what I feel is like considering the prerequisites array given to me as the input here, there is a direct dependency, or maybe there is an edge from AI, or let's say you must have to take BI first if you want to take course AI. Take BI first if you want to take AI. So in order to complete AI, you should have BI first. So this reminds me of something called as a topological sorting. So I will represent a graph in the form of adjacency list, and then I will see if I could generate a valid topological sort uh, like through the prerequisites given here. If I am able to generate a valid topological sort, that means there won't be a cycle existing in that particular like let's say the directed graph, and hence I can complete all the courses. Else if I cannot actually generate a valid topological sort, that means there exists a cyclic dependency in the courses. That means, like as you really mentioned here, in order to take 2 you should have taken 1 first, and in order to take 3 you should have taken 2 first, but in order to take 1 you should have taken 3, which is like extremely impossible, because uh, 1 which is uh, actually after 3 in the graph given here appears actually before 3. So there isn't any valid topological sort, or there exists a cycle in the graph, and hence you cannot actually finish all the courses.
Cool. Yeah, I think that would make sense.
Yeah, but I am actually thinking like what should be the directed edge from. So in order to take BI first, you in order to take BI, you have to actually take AI. So AI should come before BI in the topo sort. Only then you can actually complete the uh, courses, all the courses. So
Yes.
so I feel there has to be a directed edge from AI to BI. Am I correct? Like, did
Yes,
you,
you are
yeah.
correct.
Uh, okay. I'm like coding directly up. So you got like the algorithm of what I want to do, right?
Yeah, I got the idea.
Yeah, sure. Okay. So for so adjacency of, so there exists a direct connection from A to B, and hence I of A of 0 underscore that of prerequisites of I of 1. So I feel this will like set us up with the adjacency list of what I was talking, where I can like generate and see if there exists a cycle or not in the directed graph, or maybe see if there is a topo sort, valid topo sort or not.
Cool. Oh,
Yeah,
just one more question. So
yeah,
when you say you are preferring adjacency list, there
yeah,
are actually a couple of ways to represent a graph. Adjacency list, adjacency matrix.
yeah.
Do you think adjacency list would be the correct way to go in this case?
I feel yes, because like you only need to have the track of what the current ith node is connected to, and not like the way we represent in the matrix. Because in the matrix it is like a square matrix where you have let's say it is represented, as you said, it is zero based indexing, so it is represented in num courses star num courses dimension. So so every course, if it is directly connected to the other course, it there would be a one, which I feel is like too much complex to traverse and find if there is an edge from the ith course to its children, or maybe the neighboring node courses.
Cool. Yeah,
Yeah.
I just yeah, I think you are correct on that as well. Yeah, you can go ahead.
uh, okay, so okay, I am assuming like one graph where you have just 1 2 3 and then one. Okay. uh, so what I'll do is I'll create a stack for the integers to store uh, to literally store all the uh, uh, numbers which have completed their DFS call. So why I mean to do that is because, like, let's say you have 1 2 3 and then 1. So when you start the DFS call of 1, it will propagate its function to the node 2, and then it will propagate it to 3, and then to 1, where you kind of understand that you have actually completed the DFS of 1, and then I push it into the stack. And similarly, the DFS call for 2 or 3 will also start. And once they don't have any more children to visit, or all the neighboring nodes are visited, then I'll like probably push it back to the stack.
Cool.
Yeah.
Yes.
So I will start. Okay.
Like even if you can write just number of code, you don't have to be exact about the syntax. Don't worry about it. Yeah.
Sure, sure. Yeah. So I'll call a DFS function considering the current course, like the ith course, and I'll also pass the adjacency list. And yeah, that's it. Like, I feel I also have to pass tag. Yeah. So at the end, like I will let's say basically uh, see if the size of the stack is equal to okay, so I can like directly return if stack size is equal to the num courses. So if this thing is true, that means there is a valid ordering of the courses, and then uh, I can basically return true. So, and if there exists more, or let's say like in the previous case where you took 1 2 3 1, here like in the stack you will have like one will complete its DFS call thinking that it is already been visited. So hence one will not be pushed, and hence there will be lesser number of nodes in the stack, and hence this condition will be negated, and hence it will return false. Am I like clear?
Yes, you are clear. Uh, just one more thing.
Okay.
So, do you know what would be like the most efficient way to identify that? Basically, what you are doing is you are trying to see if a cycle exists or not.
Yeah, sure. Yeah.
Yeah. So, what is a common logic for any DFS function if you want to determine a cycle is present or not? So, let's
uh,
say you are
I
given the
I get.
example of, yeah.
Yeah. So if let's say you keep a track of like the visited array of all the number of courses, and if there exists an attached, like if the children node is not visited, that means if it is currently not visited, then you mark it as visited and you do the DFS with that node. But if it is actually visited and it is not visited through the parent, that means there exists another edge from some other thing where you are like basically having a cycle. Am I making sense?
Yeah. So basically, since it's DFS, you start from one particular node. You
Yeah,
are going to go over every single other nodes that are connected or that are the edges of that node.
got
Correct?
it. Yes.
Yeah. It could also be possible that even for some other node. So suppose you are given a condition where, let's say, okay, currently core in order to complete course number 1, you would have to complete course number 2.
Yeah.
Same way, in order to complete, let's say, course number 3, again you would need to have completed course number 2. But
Yeah.
in this case, you can complete all three of them, because if you just complete course number 2, you would be eligible to complete course number 1 and course number 3. So though you are visiting course number 2 twice, there is no cycle in this case.
Yeah.
But suppose you are in a condition where 1 needs to like 2, again 2 needs like 3, and again 3 needs like 2. So in a single DFS call, if you are able to like get the same value again, in that case a cycle has been detected.
Yes. Yes.
So yeah, yeah, but
So
in
yeah.
yeah,
So that thing can like be handled by the help of backtracking.
correct.
Yeah. So where you mark the current node as unvisited or like false, where you are backtracking, and then it will help the other nodes to actually to complete their DFS call efficiently.
Cool.
Yeah.
So
So should I execute this logic now?
do you think that that would make the code more efficient or less efficient?
It will actually it will make more efficient just in the way of you visualizing, but I don't think there will be like a drastic change in the time complexity of the code, because as of my knowledge, this is like the topological sort where you also have to traverse the whole graph and find if there is a valid sorting. That will also take O of what do you call that?
E plus V.
E plus V log. Yeah, E plus V.
Yeah,
Basically, big of V, E plus V. And even the cycle will also give big of E plus V. But this is something like a pruning case where you, if there isn't a valid thing, that if there exists a cycle at any point of time, you directly return false from there. So some or the other way, asymptotically, it will reduce the time complexity, but in the worst case, it will again be big of E plus V.
correct. So in a general
Yeah.
scenario,
Yeah.
this would make things more
More.
efficient.
Yeah. Yeah.
Yes.
Sure. Uh,
So can you please execute? Yeah, I think it would, because say if you are building this program in actual job, you
yeah.
don't want like a worst time complexity to be same. If you, the moment you identify that this is where we identified a cycle, why do you need to go and compute all the remaining 50 nodes?
Exactly. Yes, I get
Yes.
it. Yeah. Okay. So currently, I'm initializing all the nodes as unvisited,
Correct.
and I'll pass that visited array to the thing, and then at the end, I'll return true. And here, if at any point of time the DFS call is like giving us false, we return directly the false. And at the end, if no DFS call is returning false, I return true. And I am running this for loop just because to make sure that if the graph is not connected and if it has different components, it will make sure to traverse the whole graph. So
Correct.
I actually have to handle this thing. So if it is not visited, only then go inside, and here if the DFS call is not false, then only you return false.
Sure. One more thing that you think you missed in this case.
Yeah.
Because here what you are doing is the moment you, it could be possible that same course is a prerequisite for multiple other courses.
Yeah.
So here you are marking it as visited the moment you
No,
visit that course.
I don't mark it visited here.
Yeah,
I
you would mark it as visited the moment you are going to visit the course. You would also mark it as unvisited the moment you are done iterating for that particular call. You got what I'm trying to say?
no. Can you like repeat it?
Sure. Here, so let me just go back with my example.
Okay.
Suppose, as mentioned, right? Two is a prerequisite for one, and
Okay.
uh, two is also a prerequisite for three.
Mhm.
So say you are traversing through, and currently the graph is not connect. We can consider like you are starting your DFS from one. You mark two as visited because there is a dependency, there is an edge.
Okay.
When you start DFS at three, if you
Mhm.
and would you find two as visited in your code, or you would
No,
find two as, yeah, you would, yeah. So you
unvisited.
would revert it back, right? You would
Yeah.
revert it
Yeah.
back
Yeah.
the moment you are done with the DFS call from three, from one.
One.
Yeah, yeah. So I think I'm good with this one. I think you would be able to execute the code. Uh, and your time and space complexity is V plus
Uh,
E, correct?
v plus e and yeah, we got v plus e. Yes.
Yes. So yeah, I think I'm good with this approach. We still have time. We can move on to the next question. So please read through the question and let me know if you have
Okay. Sure.
anything. Yeah.
Please. Mhm. Okay. Okay. Can you give the code snippet of the function which I have to like execute?
Sure. So
Yeah.
this would be the code snippet. If you want, I can give you a couple of examples as well. That would
Yeah.
make
That
that
would
would
also.
yeah. Let me first give you the example, and then this is one of the examples. If you want, I can walk through the example as well, or you want to read it first.
Okay. Once I like go through, and if I have any doubt, I like ask you.
Sure, of course.
So, okay. Okay. So the should print message will like call. Got it. I understood.
Okay.
Okay. So here, like I have a doubt. Should I like consider this call as the latest call for this thing, or I should consider the earlier one only?
So typically, for the moment you see the first entry,
Okay.
that you would mark it as the first call. So in
Okay.
this case, since you saw the foo as the first entry,
Okay.
you would mark that you saw a message foo at 1 second.
Okay.
So from 1 second to 11 seconds,
Mhm.
If you see foo in between any time, you would simply reject that. But in your logger system, you would still have foo as the entry that came in at 1 second.
Got
And
it.
say on the 12th second, if the message foo comes again,
Mhm.
you would basically you would have dropped the foo that came on 1 second because it already exceeded 10 seconds. And from the next input for the foo would be at 12 second. And if you see foo at, let's say, 15, you would again drop it.
Okay, understood. So the valid printing will be the latest one to actually like assume it, right?
So the valid printing would be that the first unique entry.
Yeah. So here you have the first unique entry, and hence that is not actually present in your logger system. So
Correct.
you print it, and here
Correct.
you have actually it in the logger system, and the time is actually less than 10 seconds. So you won't actually print. And
Correct.
the same goes with the 10 seconds thing. But at the
Yes.
11 second, as it is actually present in your logger system, but as the time is actually the difference between the time of arrival for the first one which is in your logger system and the second one which currently came is greater than or equal to 10 seconds, and hence you actually can print this onto the console. And now the time the uh, foo will actually be updated with the current time for 11 seconds, and then uh, the next message valid can be printed at 21 seconds, and
Cool.
no messages in between.
Yes, exactly.
Yeah. uh,
I also pasted the coding
Understood.
logic that you are basically given the timestamp and the string message that comes in as the input. You would need to make sure that whether that is what the boolean method is asking you to do. And in the public logger method, you simply need to input the logic of all the values you are going to. Okay.
Great, great. Okay. So what I feel is this is related to the uh, related to storing messages in your logger system. And as this is handling a stream of data, you basically maintain something called as a set outside of the like as a container, as in whenever like like the queries come in as a stream, you basically check in the set if the current thing is existing or not. If the message is existing and is actually greater than or equal to 10 seconds, you basically pop the existing one and you insert the new one just to update the database. But else you actually won't update and you won't print anything into the thing. So am I like making sense?
Yeah, you are making sense.
Yeah. So okay. Okay, sure. So I will
By the way, for this approach, what would be the time and space complexity?
this will be uh, it will be like in the order of in the worst case it will be in the order of the number of calls should print message will get. It will be considering the amount of calls it will like this gets calls as n, it will be in the order of n log n in the worst case if I use a set data structure. And if I use an unordered set, and asymptotically speaking it will be in the order of big O of n. But in the worst case it will also turn out to be big of n log n.
Sure. Do you think you can do something better with the time complexity?
Okay. Do you mean to n big of n or big of log n?
What would be the best time complexity you would be able to come in this case? Try to okay. Don't think about queue set in that those terms. Think about it that okay, a message comes into you.
Mhm.
You simply need to check that whether you have seen that message in the past 10 seconds or not. If you have not seen it, you simply you should know immediately that okay, I haven't seen this message. Let me print this. Let me store the timestamp it came up with. So for the next 10 seconds, if the same message comes in, I can just simply discard it.
Yeah. So what I feel is like you don't know what messages will come, and hence I don't think you can actually okay. Uh, I don't think like there is some optimality getting into my mind. Uh, uh, Give me more time. I like read out. Okay. Okay. Mhm. Okay. I don't find any like optimizations. I feel like OAuth and login would be the, because we don't know like let's say if you are trying to use a vector, you can you cannot like actually fix a size for it. So let's say you're at the first timestamp, you have something like foo. So I'll like basically store the vector of one. Basically, it's a vector of vectors. Let's suppose, and you push foo into it, and let's say at second stamp, then the same foo came. Then at the second stamp, you push bar, and at the third time, if foo came, okay, you
Okay, quick question.
yeah.
Any data structure that comes to your mind that is able to identify any message, that it can check that whether this message has previously came or not in constant time? Don't forget about timestamps for the moment.
Understood. Understood.
You simply want to know that whether that message has came before or not. If it has, you simply need to know that, okay, immediately I need to know if this message has came before, if I have seen this before.
Okay. Actually, unordered map and unordered set works in big of one for like finding if the current message exists or not.
Correct. So through a hash set or through hash map, say
Yeah.
in the hash, say currently we are only focused that whether you've seen this message or not.
Yeah.
For that part, if you use the hash set, you should be able to immediately identify that if I have seen this message in the past or not. So that solves one of your problem. But the problem you are trying to solve is that you want to check that whether this message has came in last 10 seconds or not. For
Yeah.
that,
So
you would
that's
need
what
to
I
have the valid.
earlier mentioned, that I'll actually store a pair of integer and string in the set, or maybe you can actually use an unordered map as well.
You can, yeah, if you use just simply hash map, you
Hash map.
would eliminate,
Sorry.
you would eliminate the need to use queue, and go through the queue to dequeue that value. You can simply use a hash map to determine that whether the, and because in the hash map, how a hash map is structured, it's a key value pair mechanism.
Yeah, I understood.
Yeah, as a key, if you put the string, as a value, if you put the initial timestamp
Understood.
for all the upcoming values, you would be able to find that whether you have seen that or not. In constant
Yeah,
time, you can return true or false.
yeah. That's what I like actually said earlier, like
Yeah,
before.
but mm, using the queue to like
No,
dequeue all those
I
values,
didn't
that would,
actually use keyword. I said
okay,
like the unordered set using pair or the
okay,
normal set. Yeah.
okay. Oh, sorry,
Q Q won't
I
like
got confused.
yeah, Q won't make sense actually.
Yes,
You would either use a map where you can store key value, or you use paired where in C++ you have something like a pair of string comma int.
yes,
I'll develop a set of pair string int, which will basically store, like, let's say you have uh, like foo and one. So okay, sorry. So you will store this, and once like let's say foo and two came. So in the set, so this is like the set, and you'll basically have like many tuples inside the set. So
correct,
let's say like foo two came, the it will begin, like the hashing will begin, and it will search basically if there exists a foo, and then if it exists, it will see if the timestamp is like the difference between the current timestamp and this is greater than or equal to 10. Then this will be popped out, and the current one will be inserted. Else you
correct,
return false.
correct. Yeah, so that logic would make, yeah, yeah,
So okay.
yeah. I think I'm good with the explanation now. I got, I think I misunderstood before, but
Yeah,
thanks for clarifying.
yeah,
Yeah. Oh, by the way, I am pretty sure you would be able to code this one up
yeah,
because
yeah.
yeah. So I think uh, we can call it as like end of the technical round. You can stop sharing your screen. So I think what is your assessment?
So what I feel is like I was okay, good enough to handle the pressure and to understand the question and ask about the constraints, think of optimizing as much as possible. Like I love the fact of uh, uh, having understood your hint of optimizing the first code to two variables. That thing I actually loved, where I got the idea immediately that I can use like two variables to optimize the code. And the second problem was also very good. Like I actually thought of implementing it using the toposort, but you gave like the technique where you can actually return at the current moment, instead of like doing everything and then seeing if I can schedule the courses or not. And the third one like was pretty much straightforward, where you can actually use a set or map data structure to find if there exists, and if there exists a thing, and if it is less than or equal to 10 seconds, you don't do anything and you return false. Else you pop the earlier one out and push the current one with the updated timestamp. So
Correct.
that's yeah.
Yeah. So I think your assessment is absolutely on point. You have good knowledge of data structure and algorithms. You can think that what could be different things that can put in place. You are not too committed to your initial solution. You adapt and learn, and you adapt and improve. So that's a good quality. That's typically what, because many times there are thousands of questions. You won't be able to know that what is the optimal solution and how it works, but you at least you try to improve, and that is the idea, that build a brute force solution or build any solution first, and then try to see that what could be better done, what could be better done. And you ask, I would say you ask good clarifying questions, but I think it is too limited to like always you try to ask that what is going to be the exceeding limit.
Okay.
One more thing you can consider is that try to find what could be edge cases or what could be like unexpected inputs. So for the second question, the course schedule, one very important question that you could have asked is that are we guaranteed to have all the values to be unique in the input array?
Okay.
Yeah. So things like that. Just an example. I'm not saying that you should come up with the exact question all the time, but
Okay.
try to also think that rather than thinking about this as an interview, try to think that you are working with your friend or a colleague and you are trying to see that, okay, what could be the solution? And then you just brainstorm the idea. That would make the whole process much more fun and much less pressurized. You wouldn't have to be and in my opinion, given the background that you are working in probably the coolest technology right now on the planet. You
Yeah.
are you also have good amount of knowledge in DSA, and you are still studying, so you still have one more year to prepare, I would say. So you can definitely target for FANG or any company. Like even there are good non-FANG companies as well who pays really good salary and they do a lot of cool stuff. So
Yeah.
try to improve upon that, and I would suggest you to try to build your LinkedIn from right now. So keep posting all the cool stuff that I haven't seen your LinkedIn, but I assume that if you start doing it from now and try to connect with as many people as you can, it would always work in your favor.
Yeah, yeah, sure. I actually have a habit of maintaining LinkedIn, but like uh, I don't like post much of what I do, but rather I'll be updated with what the current technologies, the like the IT industry is working, and what like are the updates, and how are people like making or striving hard to focus on what their career goal is. And I recently came in touch with your YouTube channel through Reddit actually, where
Yes.
the earlier interview one or someone might like posted about your channel, and I felt it was like very. I scrolled through the content, I watched 2 or 3 videos, I felt it was very good, and then I like asked you through the comment section.
Yeah, no, of course. So it's good that you are proactively reaching out. You are taking all of these things.
Yeah,
Try to keep doing it. Also, I would suggest since you have one more year, uh,
yeah,
try to build something in either AI or build an app or something that's going to really highlight your skills. And when you are actually looking for a job,
yeah,
immediately any interviewer they would be able to see, go to their app store and see one of the app that you have created.
yeah.
You are like your chances suddenly shoot through the roof.
Understood.
So yes, exactly. These are like the small things make that would definitely highlight your skills. So I would really encourage you to keep doing it. And
Sure.
if you don't market yourself, no one else is going to do it. So if you're doing something cool, post it on LinkedIn. Why are you shying away from that?
Yeah, yeah. I
Yeah.
understood. Yeah,
Yeah. Mark Zuckerberg didn't build Facebook just to use for himself.
understood. Yeah.
Yes. Okay.
So to recently like share about the thought which you told, like we recently participated in the Micron machine learning hackathon, and we actually got the third prize in India. Like
Yeah.
where
Oh,
we, yeah, where
so
we built a
that's a
model
huge
which could,
achievement.
yeah, where we built a model which could like as it is a burning problem of electrical vehicles. So given a map of the network of all the cities they present, let's like we assumed a Chandigarh state, where you will be given the data set of that locality, and our model will be trained. So basically we developed a Bayesian network where the model will take the factors like congestion, voltage sensitivity, and if there exists a prior charging station in that area, and it will try to predict the optimal places of deploying the charging stations.
So this actually solves a really important problem of where to put EV chargers in the
Yeah,
future.
yeah,
Yeah, exactly. This is very relevant with the current market. Recently, India found one of the biggest lithium sources in the world. So
yeah,
they are going to start implementing and being huge in EV market.
yeah,
This is pretty cool stuff. You should
yeah.
speak more about it. Like, let me know if you are interested. Maybe sometime in the future, with yourself and your team, we can have a conversation about this and
Sure.
spread the word. Yeah, let other people know. You can also show some sampling or modeling. If you want to do it, I'm open for it. You
Yeah,
have my Calendly link, so you can book anytime. And
yeah,
just like yeah, just in the comments, just let me know that this is what I want to talk about. These are the things we could work upon, and yeah, let me also paste my LinkedIn. So
yeah.
if
That
you
that would be
want
like
to
great.
get connected, yeah,
Yeah,
just a second. If you
sure.
want to get connected, we can also work upon that because these are pretty cool stuff.
Yeah,
And I'll just paste it in the chat so you can check it out from there.
Sure.
There you go. Okay, so it was really nice meeting you, Sanket. Any tips on my end that you think I could have done better? Yeah, definitely I could have done better listening to your solution in the last part. I think I missed out on that, so my bad. But
Yeah.
anything else that I could have improved upon?
Like specifically, no, because like I am very new to getting interviewed with the FAANG or like let's say software development style, but I felt you were very supportive. Like you kept on giving hints and giving me the direction of how I should think. Probably that thing I felt when like literally when we just began our interview, where you helped me to understand that you can actually space optimize it to like two variables. That is like the main thing, without like wasting the extra space of big offhand. And you were actually also very supportive in giving the test cases, asking me if you want to explain or dry run me out with the example given. So yeah, you were very supportive and amazing. Thank you.
Yeah, just one more thing. Don't expect this in the actual interview. Actual
Yeah,
interviews are trained
that
to
is why
be
I
trained to
feel like
create the
you were
pressure.
very
Okay.
supportive. Yeah.
So yeah, sure. Okay. Thanks.
Yeah.
See
Yeah.
you. Bye.
Bye. Thank you.